Welcome to the new era of computational linguistics, where breakthroughs in artificial intelligence and language are reshaping how we communicate. In this episode, we explore 50 new research papers from July 2025, unveiling advances in AI-powered communication. From the latest large language models to real-world impact in healthcare and beyond, today's focus highlights memory, inclusivity, and practical applications. Our featured paper of the day spotlights work by Corbeil and colleagues on healthcare natural language processing. Let's embark on this journey through the latest frontiers of language technology. Imagine a world where your phone not only chats with you about your health or travel plans, but does so with empathy and a touch of humor. Artificial intelligence now adapts to your culture and personal history in real time, blending fact, memory, and imagination seamlessly in its responses. Surprisingly, much of this capability is already within reach. Yet, as reality and AI increasingly blur, important questions emerge. What happens when machines understand us so well that the distinction between human and machine memory, imagination, and fact is no longer clear? This is the landscape we explore today. Computational linguistics matters because language is the bridge between humans and machines. It powers everything from web search and translation to digital assistants that help us in daily life. By uniting the disciplines of artificial intelligence, logic, and linguistics, computational linguistics advances smarter, more empathetic, and inclusive AI. In July 2025, 50 research papers push the boundaries of communication technology, aiming for solutions that are not only technically robust, but also socially responsible. Join us as we delve into the themes driving today's research and uncover how these advances are shaping the future of language and technology. Consider human language as a vast city, with grammar forming winding roads and vocabulary towering as skyscrapers. In this analogy, computational linguistics serves as urban engineering. Researchers are the architects and city planners, mapping, constructing, and maintaining the pathways that enable artificial intelligence to navigate language. Algorithms and extensive datasets are the essential tools powering AI's journey through this landscape, allowing machines to learn local customs and adapt to diverse communicative contexts. Language technology now enables global and accessible interaction, bridging cultures and making communication more inclusive. The first major theme is the power and limitations of large language models. Imagine these as high-speed trains in the city of language. Models such as GPT-4o and Gemini 2.5 now manage not only text but also video and ongoing dialogues, with capabilities to remember previous interactions, plan, and reason through complex tasks. However, these models are not infallible. A technical challenge known as hallucination occurs when AI invents facts or overlooks important details. Researchers are investigating how these models learn, generalize, and where they sometimes fail, with Gemini 2.5's agentic, multimodal abilities serving as a leading example of both promise and complexity. The second theme centers on multilingualism and cross-cultural understanding. Artificial intelligence is being trained to process languages such as Hindi, Swahili, Thai, and Judeo-Arabic, not merely translating, but learning to appreciate cultural nuance and context. A significant challenge is the scarcity of large datasets for low-resource languages, making progress difficult. The process of translating idioms between languages is likened to transplanting plants between different climates, requiring adaptation and sensitivity. Recent papers demonstrate progress in cross-lingual reasoning, advancing inclusivity in global AI communication. A third driving theme is the pursuit of responsible and inclusive artificial intelligence. Bias, privacy, and online safety are at the forefront of research. The MODELCITIZENS project exemplifies a novel approach to toxicity detection by incorporating diverse community perspectives rather than enforcing a single standard. This is analogous to a city council where every neighborhood has a genuine voice. AI systems are being trained to reflect the lived experiences of various identity groups, ensuring that safety and fairness are prioritized in real-world applications. Key research findings are shaping real-world impact across healthcare, safety, and reasoning. Corbeil and colleagues developed AI systems that extract clinical data from speech, significantly reducing the documentation burden on nurses. Suvarna and her team introduced community-based moderation, enhancing fairness in online content moderation. Tao and collaborators uncovered a phenomenon where language models miss critical information presented late in documents. Their COPE framework addresses this challenge. OpenS2S democratizes empathetic speech modeling, supporting wellness technology, while LCDS offers logic-controlled medical summaries, ensuring every claim is traceable to its source. Today's featured paper, Empowering Healthcare Practitioners with Language Models, authored by Corbeil and colleagues, addresses the overwhelming clinical documentation burden faced by nurses and doctors. Their research automates the extraction of structured data from real-world speech, focusing specifically on nurse dictations and doctor-patient conversations. This effort led to the creation of the first open datasets in this domain, Senior for nurse observations and SimOrd for medical orders. The team balanced realism and privacy by leveraging synthetic data, setting a new standard for secure and effective clinical natural language processing. Delving into their methodology, Corbeil and team utilized both open and closed-weight models, including GPT-4o. An innovative agentic pipeline was employed to simulate realistic, non-sensitive nurse dictations, generating synthetic data that is both lifelike and privacy-respecting. These open-source datasets enable reproducible and transparent research in clinical natural language processing. In terms of performance, closed-weight models initially excelled, but open-source models demonstrated competitive results with careful tuning, highlighting the trade-offs between proprietary performance and community-driven adaptability. The impact of this work extends beyond technical achievement. By easing the burden of clinical documentation, the research promises to reduce burnout among healthcare professionals. These are the first public resources in clinical natural language processing for speech, inviting the broader community to build upon, critique, and enhance the tools. The project sets new standards for open and inclusive healthcare AI, underscoring the importance of balancing immediate system performance with long-term transparency and adaptability for the benefit of all stakeholders. Looking to the future, the field of computational linguistics may be envisioned as an expanding library, growing ever more multilingual and diverse. Artificial intelligence will increasingly adapt to each user's language, background, and needs. Deeper integration of cognitive and social science theories is anticipated, fostering more human-aligned models. Open science initiatives comprising new datasets, benchmarks, and collaborative opportunities are set to accelerate progress. The envisioned future is one where AI systems remember, reason, and consistently respect privacy, personalizing interactions in meaningful ways. In conclusion, computational linguistics is fundamentally transforming human communication. Recent breakthroughs in model memory, inclusivity, and real-world applications are propelling the field forward. Persistent challenges remain, including data scarcity, model hallucinations, bias, and brittle reasoning. However, progress is being driven by open science practices and the active involvement of diverse communities. Engagement, critical inquiry, and collaboration are encouraged as each voice contributes to shaping the future of language technology. This presentation was synthesized using GPT-4.1 technology for language generation, as well as text-to-speech and image generation systems. Human experts reviewed and curated the narrative to ensure quality and clarity. While every effort was made to maintain accuracy, some limitations or oversights may persist. References for all cited works are provided for transparency. This process reflects a collaborative partnership between artificial intelligence and human expertise to deliver trustworthy, high-quality content. Stay informed on the latest breakthroughs in artificial intelligence and computational linguistics by subscribing to AI Frontiers. This channel offers expert insights and accessible explanations, keeping you up to date on cutting-edge research. Your feedback is invaluable and directly influences future episodes. Thank you for being an integral part of our journey. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from the arXiv preprint server, from neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.